Hi friends, today I will discuss on testing for equality of proportions. Suppose we are studying the characteristics of two independent populations. Here our interest is to test whether the two populations proportions are equal or to whether the two populations are identical. That means the proportion of individuals possessing the characteristic in one population and proportion of individuals possessing the characteristic in another population, they are equal. Accordingly, we set up the null hypothesis and alternative hypothesis as follows. As you know that the null hypothesis should be always neutral one. So that means capital P1 equal to capital P2, that is equal to say capital P, where P1 and P2 are the two population proportions. Against the alternative H1, P1 not equal to P2 means it is a two-tailed test, means your rejection region lies on both the tails of the distribution. Or the alternative H1, P1 greater than P2 means it is a right-tailed test where the critical region lies entirely on the right tail of the distribution, or H1 P1 less than P2 means it is a left tail test. In order to test the above hypothesis, we have to draw a random sample of size N1 from the first population. Among these N1 samples, some X1 individuals possessing the particular characteristic. Therefore, the first sample proportion P1 equal to X1 divided by N1. As you know that X1 by N1 means it is just like favorable number of outcomes by total number of outcomes. So this X1 means number of individuals possessing the characteristic in a sample of size N1 which can be drawn from the first population. And we know that X1 follows binomial distribution with parameter N1 and population proportion capital P1. From the second population, draw a random sample of size N2. Among those N2 samples, some X2 individuals possessing the particular characteristic. Therefore, this second sample proportion P2 equal to X2 divided by N2. Here also X2 means number of individuals possessing the characteristic in a sample of size N2 which is drawn from the second population. Therefore, X2 follows binomial with parameter N2 and population proportion capital P2. Our interest is to estimate the difference in proportion or equality of proportions. So, our alternate null hypothesis P1 equal to P2, or in other words P1 minus P2 equal to 0. Therefore, P1 minus P2, difference between the two sample proportion, which is an appropriate statistic for estimating the difference in the population proportions. So, P1 minus P2, if you take the expectation, then it becomes expected value of P1 minus expected value of P2. So, as you know that expected value of P1, expected value of P1 means if you take expected value of this term means expected value of X1 by N1, here expected value of X2 divided by N2, that is equal to E of X1 by N1 means it is 1 by N1 into expected value of X1. So, expected value of X1 means mean of binomial distribution, that is N1 P1, and variance of X1 means it is N1 P1 Q1. So E of x1 means n1 into p1 minus 1 by n2 into expected value of x2. Expected value of x2 is nothing but mean of this binomial distribution, that is n2 p2. So one n2 cancel, one n1 cancel, so remaining is p1 minus p2. So left hand side, expected value of the difference in the sample proportion, that is equal to right hand side, means difference between the population proportion. So this is nothing but your definition of unbiasedness of an estimator. So that means P1 minus P2 is an unbiased estimator of P1 minus P2. That means difference in the sample proportion is an appropriate statistic for estimating the difference in population proportions. Similarly, if you consider the variance of P1 minus P2, as you know that variance of P1 minus P2, it is nothing but sum of the variances, variance of P1 plus variance of P2. We know that variance of P1 means it is variance of x1 by n1 plus variance of x2 by n2. So variance of Ax means a square into variance of x. So that means 1 by n1 square into variance of x1 plus 1 by n2 square into variance of x2. That is equal to 1 over n1 square. Variance of x1 means variance of the binomial distribution, that is n1 p1 q1 plus 1 by n2 square. Variance of x2 means n2 p2 and q2. So 1 n2 cancel, 1 n1 cancel, so remaining is p1 q1 by n1 plus p2 q2 divided by n2. So this is variance of p1 minus p2. So if you want the standard error of this statistic, then it is nothing but standard error of P1 minus P2 equal to root of variance of P1 minus P2. That means P1 Q1 by N1 plus P2 Q2 divided by N2. Under H0, the standard error of P1 minus P2 equal to square root of, under H0 you have taken P1 equal to P2, both are equal to capital P. So that means P1 is replaced as P, so that Q1 becomes Q by N1 plus here also P2 also equal to P, therefore Q2 becomes Q divided by N2. So that is equal to taking PQ outside 1 over N1 plus 1 over N2. This is standard error of P1 minus P2 under H0. Under H0. So what is this P? So P is nothing but P is unknown. Therefore, the estimate of the standard error becomes standard error of P1 minus P2 equal to P cap into Q cap 1 over N1 plus 1 over N2. What is this P cap? P cap is nothing but the pooled proportion or combined proportion which is obtained using the pooled sample. That is P cap equal to total number of individuals possessing the characteristic in the two samples divided by total sample size N1 plus N2. So this can also be written because P1 is nothing but x1 by N1. So if you cross multiply like this, N1 into P1, that is equal to x1. So N1 into P1. On the similar manner, if you write P2 as x2 by N2, on cross multiply we get the value of x2 as N2 P2 divided by n1 plus n2. So this is called as combined proportion, so that q cap equal to 1 minus p cap. The test procedure suggests that, or before that, the test statistic is given by z is equal to p1 minus p2, that is called as statistic, minus mean of the statistic capital P1 minus capital P2 divided by standard error of the statistic P1 Q1 by N1 plus P2 Q2 divided by N2. As you know that using the central limit theorem, the distribution of P1 minus P2 is normal with mean capital P1 minus P2 and standard error is like this. So the test statistic is given like this, but under H0 P1 equal to P2, that means P1 minus P2 becomes 0 and P1 and P2 both are equal. So under H0 you have already computed the standard error, hence under H0 the test statistic is given by P1 minus P2 minus 0 divided by standard error, that is PQ into 1 over n1 plus 1 over n2. This tends to normal 0, 1 for large values of n1 and n2, for large values of n1 and n2. The test procedure suggests that reject H0 if mod z greater than or equal to z alpha by 2, where z alpha by 2 is obtained from standard normal distribution table such that probability mod z greater than or equal to z alpha by 2 equal to alpha, where alpha is the level of significance. So this is for two-tailed test. Similarly, reject H0 if z greater than z alpha, where z alpha is obtained using the size condition that probability mod z greater than z alpha under H0, that is equal to alpha. So it is a right tail test, or if it is left tail test, the critical region is z less than minus z alpha. That means reject H0 if z is less than minus z alpha, where z alpha is obtained using the size condition that probability z less than minus z alpha, that is equal to alpha under H0. So this is about the testing for the equality of proportions. So thank you. I will discuss the next topic, that is testing for correlation coefficient, in the next section.